In Chapter 6, we're going to study linear functions. We're going to be building off of graphing linear relations and recognizing the properties of linear relations. And the big idea is the graph of a linear function is a non-vertical straight line with a constant slope. And there are certain forms of the equation of a linear function, and we'll learn 3 different forms. Some of the new vocabulary this chapter is slope, rise, run, negative reciprocals, slope-intercept, slope point, and general form. So in section 6.1, we're going to talk about the slope of a line. For a linear relation, we can calculate the rate of change by taking our change in the dependent variable divided by the change in the independent variable. And again, this is slope, which is rise over run. And if we're looking at the slope between 2 coordinates, it's y2 minus y1 divided by x2 minus x1. Now, a little preview for calculus. In calculus, we are often trying to figure out the slope of a tangent line, and sometimes we also look at the slope of a secant line. So slope is something that you're going to see much later on in other math courses, and it's actually quite an important part of calculus. Determine the slope of each line segment. Okay, so to figure out the slope, one way of doing it is taking my point here and my point here and looking at my change in x and my change in y. So my change in x, I'm going from -6 to +4, so that's 10. My change in y is going from -3 to +3, so my change in y is 6. So therefore my slope, the symbol we use for slope is m, is 6 over 10, which is equal to 3 over 5. Now, to figure out the slope of line segment CD, again, we could use the endpoints. And I could go here and say, okay, this is a change and this is change. So my change in y for this line segment, I'm going from 4 down to -6, and I'm going down. So therefore, it's -10. And my run is going from -3 all the way to 2. So my change in x, is going to be 5. Whoops. So therefore, my slope is going to be 10 over 5, which is going to be equal to 2. All right, a positive slope is a slope that the line is going uphill and increases from left to right. The y values are getting bigger. A negative slope, the y values are getting smaller, and the graph is decreasing from left to right. A zero slope is a horizontal line, and a vertical line has a slope that is undefined, and we talked a bit about that back in chapter 5. Okay, we want to draw a line segment with a slope of 7 over 5. So again, take any point. I'll start with a point right there. I'm going to go up 7, 6, 7, and over 5. 1, 2, 3, 4, 5. So again, this is my change in y. This is my change in x. And I'll join those two, and that would be my line segment. For the line segment, -3 over 8, again, that means I'm going down 3 and over 8. I'm going to start, say, right here. I'm going to go down 3 and over 8. And again, I would draw my line segment right there. All right, to say we want to determine the slope of the line passing through the point -5 and -3 and 2 and 1. So -5, -3 is this point right here. And point B is 2 and 1, which is right there. And we want to find the slope of that line. Now, without even graphing it and counting rise over run, we can use our slope formula. I'll call this point x1, y1, and this point x2, y2. So to figure out the slope, it's y2 minus y1. So it's going to be 1 subtract -3 divided by 2 subtract -5. And this works out to be 4 over 6, which reduces to be 2/3. In our last example, we're looking at an application question, and Yvonne recorded the distances she traveled at certain times since she began her cycling trip. What is the slope of the line through these points? Well, again, if I was to draw a straight line through these points, Okay, this would be my change in y. In this case is 24, and my unit in this case is kilometers. And my change in x would be 1 hour. So my slope would be 24 kilometers over 1 hour. Which means she is traveling 24 kilometers per hour. So what does the slope of these lines, the slope we figured out part A already, what does the slope represent? Well, this represents her speed. And how can the answer to part B be used to determine how far Yvonne traveled in 1 hour, 1 3/4 hours? Okay. Well, we have a couple of ways we could do this. Number one, we could develop the equation for this particular line, okay? And if we did that, we notice our y-intercept is 0. So in this particular case, I'm going to have my distance is going to be equal to my rate of change, which was 24t. And since my horizontal intercept was 0, it's plus 0. So now to figure out the distance she traveled in 1 3/4 hours, it would be B is 24 times 1.75, which is 1 3/4. So 24 times 1.75 is going to be a distance of 42 kilometers, assuming she keeps a constant speed. So that's part C, Roman numeral 1. And then Roman numeral 2, they want us to figure out the time it took her to travel 55 kilometers. So that means I know my distance. So 55 kilometers is going to equal 24t. And now to get t by itself, we divide both sides by 24, and it would be 2.29 hours would be the time. Okay, there is the end of section 6.1. There's also a handout that I'll give you in class to work on, so please give these questions a try, and if you have any questions, check the answers on the website.